Chapter 11. Gravity acts only in the normal plane, the forgotten constraint of nature. This chapter develops one of the central claims of the universe. The argument begins with a simple question: what part of a body's motion can gravity actually change? The chapter proposes that gravity acts only in the normal direction, vertically, toward the center of mass. It therefore does not create or modify horizontal, sideways, or tangential motion. The chapter connects this claim with the classical experiments associated with Galileo. On an inclined plane, a body accelerates downward. In projectile motion, a body launched horizontally continues forward while simultaneously accelerating downward. The important distinction is between the two components. The horizontal component is attributed to the initial impulse. The vertical component is governed by gravitational acceleration. The chapter therefore asks us to look not only at what gravity does, but also at what it does not do. A projectile provides the clearest illustration. Its path is curved because horizontal motion and vertical acceleration occur together. Within the framework presented here, the curve is not produced by gravity pulling the body sideways. Gravity changes only the vertical component, while the horizontal component remains acquired from the initial impulse. The chapter calls attention to the repeated absence of horizontal gravitational acceleration. It treats this negative premise, when consistently confirmed across phenomena, as evidence for a universal constraint. Free fall gives the simplest case. When a body is released without an initial horizontal impulse, it falls vertically. There is no horizontal displacement to be produced by gravity. Now give the body a horizontal impulse. The horizontal motion appears. Gravity then acts downward while that horizontal motion continues. This distinction is extended from simple terrestrial examples to orbital motion. Within the book's framework, a satellite, a planet, or another orbiting body already possesses tangential motion. Gravity does not create that tangential motion. Instead, it provides the inward action that changes the direction of the trajectory. Thus the chapter places two roles side by side. Momentum carries acquired motion. Gravity restrains and curves that motion inward. The same reasoning is then extended to larger systems. Planetary orbits, satellite motion, and galactic rotation are interpreted as examples in which horizontal or orbital motion must have a cause other than gravity. That cause, in the framework of the book, is pressure impulse. The chapter therefore describes gravity as having both a power and a limitation. Its power is universal attraction toward a center. Its limitation is equally important. It does not act sideways. The final conclusion is that gravity should be understood as a regulator of trajectories rather than the creator of motion. Its one-directional action is presented as the condition that permits acquired tangential motion to persist. This is the forgotten constraint that the chapter asks the reader to examine. And with that distinction established, the next question becomes unavoidable. If gravity does not initiate horizontal motion, what does? The answer developed in the following chapter is impulse.